Yeah, she has it good.
Right?
I know how to spell hematopoiesis really well.
Okay. So hematopoietic stem cells, those are the cells that give rise to the myeloid and the lymphoid lineage. The myeloid are all the cells that we've talked about so far. These are all myeloid cells plus red blood cells plus platelets, but we don't talk about those. Lymphoid are the ones we're going to talk about today. The spleen filters the blood. Also, it stores white blood cells.
Don't they all
lymph
store?
nodes filter the lymph, and they store white blood cells. The tonsils store white blood cells. The thymus, what does the thymus do?
It matures the T cells.
Mature T cells, which we'll talk about today. And where are T cells born?
In the red bone marrow.
Red bone marrow. Yep, everything is born in the bone marrow. Also, what cells mature in the bone marrow?
The B cells.
Okay, let me erase this just to keep it nicer. B cell maturation. We're going to talk about that today. B cell maturation, T cell maturation, we'll talk about today. So associated lymph tissues store white blood cells. That's how important white blood cells are. They have to be everywhere.
Yeah.
Hematopoiesis is the birth of all of our red blood cell and white blood cell line. Major histocompatibility complex 1, who has that? Everyone. All cells have MHC1, and if an antigen is presented on an MHC1, what does that mean?
Kill me. It means it's infected
Infection
inside.
or cancer. Something's wrong on the inside of the cell. Okay, who has MHC2?
Professional.
Antigen presenting.
Which ones?
B cells
B cells,
and macrophages.
dendritic cells, and macrophages. And those ones, if antigen presentation, if an antigen, I'm trying to write it the same, presented on an MHC2, then what does that mean?
Go get them.
Yes, sound the alarms. Okay, we'll talk more about alarms today and what that means. So an antigen is a molecule, anything foreign. It can be the foreign body itself, it can be the whole bacteria, it can be part of the bacteria, it can be the whole virus or part of the virus. It can be, for example, rheumatoid arthritis. There's the synovial joint, the synovial pocket within a synovial joint. And in rheumatoid arthritis, our white blood cells are attacking that synovial pocket. So that's what rheumatoid arthritis is. So an antigen can be anything that the body sees as foreign. It doesn't necessarily have to be foreign. The pattern recognition receptor is a receptor on a cell, any receptor on a cell that recognizes foreign antigens. And then a pathogen-associated molecular pattern is a molecular pattern common to pathogens, like lipopolysaccharides, or peptidoglycan, or chitin, or of all the other things that we've been talking about.
Is stuff like
Oh, sorry. No, go ahead, real quick.
Oh, is Pam saying
I'm sorry, is PAMPs a what? Yeah, like an antigen, yeah. Uh-huh, yes. Yeah.
I was just gonna ask if, like pollen would be considered a PAM,
It is depending
if you're
on,
having an allergic reaction to it.
yeah,
Okay.
but usually, yeah, I mean, the reason that pathogen associated molecular patterns, we more associate those actually with pathogens than we do with just foreign materials is because pharmaceutical companies focus on PAMPs, like what sequence of amino acids or what chemical makeup can we artificially manufacture to trigger the immune system, you know, things like that. Like what are those patterns that are common to bacteria and patterns that are common to viruses? So that's kind of how they use that in that context. Okay, so the first line of defense is the integumentary system. So our skin is very strong and can defend against the first line that protects us. The blood-brain barrier as well. Chemicals, just if you can think of a couple off the top of your head, I think that one's probably pretty easy. Salt, enzymes, mucus, wax, anything. So our skin, you know how we talked about, can protect us against touching anything. But all of these orifices that we have to be extra protected because they're open to the outside world. I'm teaching about the digestive system in my other class right now and about the alimentary canal. And Hank Green on his video, he says like we're just one big donut. You know, we're open to the outside world on the inside. Our whole alimentary canal is exposed to the outside world. So how do we protect the whole alimentary canal from pathogens? It's with acids, mucus, wax, enzymes, salt, things like that. Yeah.
Can you talk about lymphocytes, or is that more directed towards the adaptive system?
I'm sorry, talk about what?
Lymphocytes?
Lymphocytes? Oh, no, we haven't talked about that. We'll talk about
Okay,
those
so-
today. Yes, yeah. Okay, so, and then, our microbiota barrier, our probiotic commensal population, those are our bacterial antagonists that help defend our body against pathogens. And then our cells were part of our second line of defense. So we have mast cells. So mast cells, what is their job?
That's a local effect.
Degranulate?
Histamines.
Degranulate histamine. So remember, these are the granulocytes. They have the grains and they're gonna spit out histamine. And where are they found? They're local. And when are mast cells triggered?
When you have acute allergies?
Yeah, acute allergies
Or
or local.
anaphylaxis?
Oh, I already put local. Anaphylaxis also, yeah. Okay, and then
Or
eosinophils.
histamine and heparin?
Histamine, heparin, and parasites. Yes. And then basophils. So if you think of chronic infection, I don't wanna say always, I should not say that. Chronic infection can lead to autoimmunity because you're triggering your immune system so much that some cell is bound to recognize something local, something innate. So chronic infections, we always worry about autoimmune. Okay, and then neutrophils, what do? They phagocytose. They
Present antigens? They're
um,
professional.
Yeah, neutrophils are kind of in that weird gray area. They phagocytose, but I don't really love to call them professionals, so I'll just leave them out of the
Okay.
story. Enzymes, they secrete toxic enzymes, cause they're also a granulocyte. And what else do they do?
They net, yeah.
Is that it? Yeah. Okay, so then they are, what do they do? Pus,
It's not,
local infection. Yes, okay. Dendritic cells, these are our professional antigen presenting cells, so sometimes they're called APCs. So they'll phagocytose, professionally antigen present. And anything else? No?
Associated with the T cells?
T cells, T cell activation, we'll talk about today. And then macrophages are also antigen presenting cells. And they clear debris. And they release cytokines, which they all release cytokines, but these are cytokine releasers. Like they call to action. And did we say anything else about these ones? They're like the Roomba.
you said they're phagos, they phagocyte, you said they're
Yeah, so they phagocytose and
Phagocytose.
antigen present. So we call
Okay.
these APCs, that's what they're called. It's like they
And they do
are the
both?
two roles. Yeah, is they
Okay.
phagocytose and antigen present.
okay.
Yeah.
What about repairing for macrophages?
Repair, yeah, they do that also, like local repair. Yeah, these are like the workhorses, and these ones have a really specific job we'll talk about today. Yeah.
I think we should have the proteins section.
Oh, yep, let's do that next, perfect. Okay, so interferons, so that's, if you see that ever in the literature, it's IFN, they have like gamma, alpha, whatever, but interferons, those are released by infected cells that are virally infected generally, and what they do is reduce gene expression. So they are act like a repressor. So if you were to choose one word, your one word would be repressor. They act like a repressor when there's a virus. Those are the things that kind of come up with interferons. Antimicrobial peptides, those are just proteins that will insert in a phospholipid bilayer of pathogens. Iron binding proteins, those will chelate iron, so they pull in iron so the bacteria can't have any iron, so then the bacteria will die. Bacteria need iron, that's all we need to know about that. And then the complement protein, which we'll talk a tiny bit more about today if we get time, but they assemble, there's tons and tons of proteins, they'll assemble to form pores and poke holes in bacteria, viruses, helminths.
And you said you didn't care if we know classical and alternative?
No, I'll talk a little bit more about it today, but I think it's beyond what you'll ever need to know, so. It's just what the classical, you might hear about it again, but the complement system is a huge part of our innate defense, and what it does is the first one will match and form a pore. That's all you need to know, really. Yeah.
I'm a little confused on what cytokines are, besides, the slide was just a little confusing.
Okay, yeah, so
Or
cytokines.
what we should focus on with cytokines.
Yeah, just that you know what they are. So cytokines are molecules that are spit out by the whole, everything will spit out cytokines to some point. These ones, especially these three, will spit out cytokines that you know how in that neutrophil video, how that neutrophil was following around the bacteria? Well, the bacteria spits out chemicals, and so the neutrophil is following those chemicals. So what's gonna happen when neutrophils and dendritic cells and macrophages spit out cytokines, the white blood cells are gonna come to the area because they sense that there's a concentration gradient of that chemical that it's gonna follow towards that chemical. It's like a chemical calling message.
Okay, they kind of just help the white blood cells do their job.
Yeah, they'll turn on white blood cells, they'll turn off white blood cells, they'll call to them to the area. So there's thousands of different kinds of cytokines, and so, yeah, they all kind of have a different role.
So when it says the proteins and small molecules, what do you mean by small molecules? If they're not proteins, then what are they?
So they can be like a chemical that's derived from, it's like some carbons and oxygens and nitrogens and sulfurs, or what, it's just a little chemical, you know, because they're not really a bunch of amino acids. There's some that are amino acids that are proteins, but a lot of them are, it's just a chemical. Yeah. Okay. Okay. So complement, and then the natural responses to an infection are fever. There's pyrogens that are exogenous pyrogens or endogenous pyrogens. Exogenous pyrogens are things like lipopolysaccharides or peptidoglycan, or some of the enzymes that are secreted by protozoa or whatever is secreted by a fungi or something like that, that will act on the hypothalamus, that will turn up the heat in the body. And then endogenous are some of like the cytokines that are released by our own cells that are going to trigger our hypothalamus to turn the heat up. And then inflammation is usually from vasodilation, from release of histamine, and that will lead to heat, redness, swelling, tenderness, because those blood vessels dilate, calling more blood to the area, calling more white blood cells to the area, and they become leaky, so it becomes swollen, and heat, because they're moving to the area. I'm sorry, what?
You mean heparin?
Histamine is a vasodilator. Heparin is actually,
Heparin was the vasodilator.
I'm sorry, what?
I thought heparin was the vasodilator.
Heparin I'm pretty sure is a vasoconstrictor. So let me look it up what heparin does, because heparin I was confused about that, but histamine is a vasodilator.
I
Huh?
thought just from the slides it said that it was a vasodilator.
Yeah, the
and-
slides did say they were vasodilators.
and
What, the
also
heparin
that-
is?
Yeah,
Yeah.
Oh, I was confused about heparin. Because I thought I knew what heparin was, but then I got confused, because I was confused what they treat, why they treat heparin, patients with heparin. But histamine is a vasodilator. I'm sorry, what?
It's a vasodilator.
What is heparin? Gosh, that is confusing to me, because why would they treat patients with a vasodilator? I don't know. Let me look it up. I'm sorry, I don't want to confuse anybody.
It's a anticoagulant, right? So like,
Anticoagulant,
It's
so
like
it
a-
helps like break up
it's like a
thrombus,
thrombolytic.
thrombolytic. Okay, that makes sense.
I-
Okay, so everybody ready to go?
No,
Let's do it.
I learned endogenous and exogenous incorrectly. Can you review that really
Endo
quickly?
is in the.
In
Exo
the
is
what?
Exit. Endo is like from the inside. So it's like endogenous pyrogens are pyrogens we make.
Okay,
Exogenous or exit
are the ones
are-
that came from somewhere else?
Yes, yes, yes.
Okay, thank you.
And that we
Yeah.
wanna get rid of those?
We want to get rid of everything really, but exogenous pyrogens is something that's foreign that will act on the hypothalamus. Like, it's cool that something foreign will act on the hypothalamus to turn up the heat, but also our own cells can turn up the heat because we're trying to kill the pathogen. Okay, so let's get going, everybody. If you can put your stuff away.